can disseminate it also afterwards. And for the questions, I propose that we keep the questions until after the presentation is given by Julian. Either you can post your questions in the chat and we will pick up on them after the presentation, or you can just press the hands up button and we will give you the word and you can ask your question directly to Julian. So I'm no longer going to keep you. So Julian, please, the floor is yours, and guide us through this interesting webinar.
Thank you very much, Marjolaine. Just to check, you can hear me okay?
Yes, perfect.
Good. Okay, yes, thank you for that introduction. And this presentation is about the work that MJC² is doing on synchromodal logistics in ePIcenter. The theme is about anticipating uncertainty, but I'd also like to give a little bit of background about the project and some of the other work that's been happening and will continue over the next couple of years. So yes, an intro to the project itself. For people that are not familiar with ePIcenter, I'll just try to summarize in a short time what's actually a very large and very ambitious project with lots of interesting technologies being considered. Today, as I say, focusing on the synchromodal logistics, but it's useful to have some background about the overall scope of the project, because to a certain extent these are issues are all linked together. The project is an international cooperation project. It's coordinated by the Port of Antwerp, and there's 36 partners in total in the consortium. The majority in Europe, but there's important inputs from partners in China, North America, and South America as well. And it's funded by the European Union's Horizon 2020 program. The technical scope is very broad. It's covering a huge range of areas. I've listed some at the top of the screen here. So digitalization and visibility solutions, artificial intelligence, new transport technologies such as Hyperloop or autonomous vehicles, excuse me, and new algorithms and techniques for optimizing ship routing and ship navigation, and a particular focus on how that can not only be used for reducing fuel, but reducing the impact on whales and other marine mammals in the oceans. The synchromodal logistics, of course, I'll be talking about today, but also a lot of these technologies relate to the emerging physical internet concept, and I'll say a few words about that as well towards the end of the presentation. From a geographical scope, of course, a lot of the interest on the applications is in the European 10T logistics network, but many of the use cases consider freight flows coming from North America or from the Far East, in particular considering the new Silk Road connections that are being established and growing very fast at the moment. And also the project's looking at new shipping routes. In particular, there's some interest in the possibility of Arctic shipping increasing in the future. So looking at impacts and issues relating to that. And of course, overall, the aim of the project is increased efficiency in global logistics networks, reduced congestion, and of course, reduced environmental impact. The consortium is a very broad scope of wide range of different partners, a lot of high-profile industry partners who are involved, working alongside technology innovators and leading universities. And the reason for this heavily focus on having industrial involvement in the project is that although the solutions are we're developing, the technologies we're developing are extremely, in some cases, very futuristic and certainly very much at the leading edge. The ultimate aim is that they have to deliver solutions to real problems. So it's important, for example, we have major ports, we have freight forwarders and logistics companies and transport operators, shipping, rail, also consumer goods manufacturers, different representatives from the supply chain and logistics operations, and it's important that the solutions developed actually address their requirements and achieve the overall goals. From a more strategic perspective, the aim is also to come up with solutions that address congestion, particularly in the 10T network, and how we can react to some of these new freight flows that I mentioned. And ultimately, of course, the big conference is kicking off next month about the environment, and we hope that a lot of these solutions contribute to the net zero efforts as well. Very briefly about MJC Squared, for people that aren't familiar with our company. We develop real-time logistics scheduling algorithms. These are used in many sectors, ranging from bulk liquids through to parcel and postal networks, home delivery type operations. A lot of these tools that I'm talking about are commercially applicable already, but in ePIcenter we're building on these capabilities, and in particular the multimodal logistics tools that we have are relevant in this case. And in ePIcenter itself, our focus is on the synchromodal algorithms and solving some of the technical challenges that these present. The optimization problem underneath is actually a very large, very complicated problem to solve, and I'll say a little bit more about that later. But the point is, as I mentioned before, we're not just developing these algorithms, then working with the industry partners, we want to prove that they can actually cope with real problems and that they can deliver the benefits that we're aiming for. So going on to the main topic for today, synchromodal logistics. First, one thing we found while talking to people, even within the project, but certainly talking to people outside the project, is that it's maybe an unfamiliar term. It's a relatively new concept in logistics. So I'll briefly explain what we mean by it and then how it relates to the topic of this webinar. Essentially, it's the ability to dynamically route and reroute freight through a multimodal logistics network. And the point is that you do this based on the prevailing circumstances, the requirements, the availability, the capacity, the status of the network, and so on. And of course, a typical multimodal logistics movement will involve several legs, several modes, whether truck going onto a barge, going onto a ship, and then onto rail, and then maybe truck at the end again, and of course all sorts of combinations of that nature. And of course, the majority of what we're doing at the moment is focusing on those modes, but with reference to technologies such as Hyperloop, there is an angle in the project also about how such modes might be used in the future. So to illustrate this with a simple example, if we have a simple case, let's say a container moving from Canada to Europe, and normally in a conventional logistics planning process, you would search for a good route. So in this case, the example is going from Montreal to Antwerp. Obviously, a truck connecting the leg at the start of the journey, and then maybe a rail connection inland, and a truck movement to the final destination. So the aim of the optimization system that we're building in ePIcenter is to, first at the planning stage, to make this a more dynamic process. So to consider many options and keep reconsidering them based on the prevailing conditions. So I might have a situation where the movement, there's an opportunity to do something a little bit different, maybe a lower cost solution and a lower emission solution, possibly at the expense of taking a bit longer, but that may be perfectly acceptable for that particular movement. It may not have quite the same deadlines as others, and so it's possible to use that additional flexibility to save costs, but also reduce environmental impact. So that is essentially the first stage of the process, is this considering in principle all options when I'm routing each container and selecting the best. But it's important to stress that the story doesn't end there. This is a dynamic reoptimization process. So as the container is in motion, and let's say it's on the ship, it's heading towards Antwerp and be arriving shortly, I still have options as to what I'm going to do with it when it arrives. So I'm not sticking to a fixed plan necessarily. I have a plan in mind that it might be going via the barge route that I described, but I've still got an open mind to change that decision as we go. And I've illustrated just with two examples here. Of course, for any real world problem, there are huge numbers of options of how you might get from a major port into the final destination, and I'll come on to that point again because it's actually key to the optimization problem. But the point is, the system is looking through all these options and picking at any point in time the best based on what's known at that time. So this leads on to the theme of the webinar about uncertainty in the supply chain, and I'm going to sort of talk about this in a few levels, in a sense. The sort of everyday aspect to this is this dynamic rerouting of freight can be used to manage what I would call normal deviations in logistics operations and manage them in an efficient way. So this is things like a ship maybe being delayed, or a last-minute order being taken, maybe a cancelled rail service, the kind of things that happen essentially on a day-to-day basis. And the concept is that the system is receiving real-time inputs. In ePIcenter, we're working alongside partners who are developing visibility solutions that provide this data, and it effectively consumes this real-time status of both the position of the container, for example, maybe the position of the transport resources, the availability, and so on. And based on that updated information, it looks for a solution to that disruption. So it might, for example, if we have a ship arriving late, we might then switch the ongoing movement from barge to rail, or maybe a combination of rail movements that ends up being a bit faster, so we can catch up lost time. And similarly with a last-minute order, last-minute orders tend to be urgent, so we might try and find a faster connection than normal for that for that A to B movement, reflecting the urgency. The point is, it's dynamic. It's automatically searching for these solutions. Having done that, it's of course the intention is that the system automates this decision as much as possible, but the user is there. They can see it on an interactive a GUI. They can have KPIs. They can manage exceptions. They can see what's going on, of course, and override the system if they want to. But the intention is that a large part of this is automated. And this has to be to a certain extent because, for example, a large freight forwarder will be managing a large number of containers. So you can't spend a lot of time thinking about each one as it changes. You've got to be fast. It's got to be accurate in the sense it's got to reflect real world constraints, real business constraints, so that the solutions that come out are actually achievable, they're feasible, they can be put into execution. And the other point about it, it has to have a sustainable focus. It can't just operate on a simplistic lowest cost or fastest connection approach, because there's other factors come into play. If you, for example, if you have a sort of use a truck as a default fallback in the case of emergency, which has often been the situation. The current conditions in certainly in Europe and many other parts of the world is there's a shortage of trucks at the moment, shortage of drivers at least, and maybe those trucks aren't as available as they once were. And in any case, of course, we're trying to use rail and barge operations or short sea connections where appropriate, because the average emissions per ton tend to be lower on those modes. So it has to be taking account of this as well. At another level, but still what I would call sort of operational planning, reactive planning, is when you have more significant disruptions, and these are sort of increasing in level of disruption, these examples. So something that's happening quite often, certainly in the last couple of weeks, has been some diversions of ships to alternative ports because of congestion. And this, from a logistics planning perspective, is not a lot of fun for the planner. They have suddenly hundreds of containers maybe in the wrong place. And so they have to find a new way of getting them to their destination. Again, the ePIcenter idea is that this would be done automatically. It would search automatically through the connections in the network and effectively string together new connections of transport modes and legs to reposition those containers to their correct destination. And of course, the same applies for export movements. If there were some exports in the port or in the hinterland about to get onto that ship, maybe they can afford to wait till the next scheduled arrival of that service, or possibly they're urgent, and again we need to reroute them via another port or another service at least. So that is one level again where the model is being used. Perhaps another step up in terms of disruption. I'm sure most people will remember the recent Suez problems, and okay, we can't obviously do much about the containers that are stuck. We have to wait for them to come out. But even then, once they have arrived at their port, there's almost certainly the onward planning of them will need to be readjusted, and that's where the algorithms come in to speed up that process. And of course, for containers that are not yet on board a ship and were planning to go that route, the system would be looking for alternative solutions effectively around that problem. And we saw that happening a lot in recent months, and it very much relates to the ePIcenter scope, the increased use of the rail connections across Asia that was triggered in part by these delays in the canal. So again, the ePIcenter model would be looking for opportunities like that to reduce the impact, at least. Of course, in something like this, it's not a case of solving the problem, but trying to reduce the problem. And the last case, of course, we hope this doesn't crop up very often, but the response to the ongoing pandemic in terms of the supply chain was that a lot of medical supplies, vaccines, other items suddenly had to be moved around the world very quickly. There was a very urgent demand for it. Obviously, we're not looking at the entire supply chain, as the manufacturing and so on is not in scope for ePIcenter, but the part where these tools can help is having decided on the manufacturing location and the destination for these items, having a system that can very quickly route them through the available network and find efficient solutions in that respect. It is potentially useful. So these are the kind of use cases that could be considered in a kind of reactive way to issues that can crop up. But beyond what I've been calling the reactive case, there's something more we can do using this approach. Obviously, we're not trying to sell a crystal ball. We can't predict the future, but what you can do is develop strategies, synchromodal strategies that effectively make the supply chain more robust to disruptions. And there's a couple of dimensions to this. One is in terms of when you're creating or looking to optimize the routing of freight around the world, the taking into consideration what the second best solution is, so that you can so that you know that if you go, or if your preferred route fails for some reason, the next best route isn't maybe too bad, and so the disruption is minimized. So that's one level that can be considered using these tools. The other is that even for a single connection, of course, you might have faster or slower options, and okay, instead of using just one or the other, you can intelligently balance the use of the two. So if you have high volume movements, and the majority of the time you can afford to use them relatively slowly, but you have the tight inventory balance at the other end, of course you can use faster connections to manage the ups and downs in demand. So by setting up an initial strategy that uses an appropriate balance of these modes, you make yourself less sensitive to fluctuations. And more on a sort of a back to the objectives of ePIcenter itself, is it also allows more sustainable optimization objectives to be defined and applied. So again, instead of just looking at cost or speed, the process can take into account the reliability of the solution and flexibility, how it responds to disruptions. So from a commercial point of view, that's obviously beneficial to the supply chain operation. And from an environmental perspective, again, you can drive the optimization to think more about emissions reduction or congestion reduction. Or even something that's becoming more in focus, I think, quality of life for not just the people generally, but specifically the logistics personnel, looking at developing solutions that are less stressed, less dependent on long shift patterns, for example, or a lot of peak demand, trying to spread things out to make things easier to manage. So having gone through this sort of I guess we could call them use cases or scenarios that the Synchromodal tools are aiming at, I wanted to just say a little bit about the approach and the functionality and the technical challenges that are being addressed in ePIcenter. The first thing is to briefly explain why this concept of Synchromodal logistics isn't actually easy to achieve, apart from other things that I'm not going to talk about today, the availability of data, and obviously there's the operational side. But just from a pure optimization perspective, it's actually a very challenging problem for a number of reasons. First, the actual size of the optimization problem is very big, and I'll illustrate that in a moment. But there's other things that we need to be aware of. We can't just have a simplistic mathematical model. It's got to take account of real operational rules, business rules, data confidentiality, all the practicalities to actually make it work in a real operation. And it's got to be fast as well. You can't have a system that churns away for hours coming up with an answer. It needs to take seconds, really, or maybe a minute or so at most. It really can't be any more than that. And the other complexity that I've touched on before is that when we're talking about finding a best solution, what exactly are we talking about? It's not simply defined. It's not just a case of lowest cost or fastest. There's other factors. There's the reliability, there's the emissions, there's many other factors, and of course it might not be just one of those. There's a combination of those, or maybe the priority depends on the circumstances. For example, if I'm moving urgent goods for medical goods, then speed is probably going to be a priority. Whereas in other situations, if it's more routine consumer goods, cost and sustainability are probably going to be a higher priority in those cases. Just to illustrate the point about the size of the search space, as it's called in optimization terminology. So basically, how many combinations we need to consider when we're doing these calculations. This is a very simplistic schematic network that I've drawn, and essentially we want to move a container from A to B. And to do that, I can go via some terminals, some inland terminals, which are the orange dots on the left-hand side. And then I take from there, I go to a port. And of course, typically in Europe, I might have several ports that I could consider at least for that movement. Similarly, at the other end, I might have a choice of ports that would make sense. And again, those ports connect to inland terminals, which again, I might have several that are reasonably close to my final destination. And then a last mile connection may probably be by truck to the to B if I need it. So you can see even from this very oversimplified network, if you imagine zigzagging through the network, finding different possible routes, there's quite a lot. I won't count them up now, but there's certainly quite a few that could be considered. And if we, these numbers are essentially made up, but they're there to illustrate the point rather than the detail. If you take any reasonable estimate for how many possible choices you've got at each stage in that process and multiply them up, you soon run into thousands of possible routes. And this, at that point, I haven't even taken into account that for a given connection, there might be multiple options. There's obviously multiple shipping companies, there's potentially multiple barges or train operators, truck operators, and even an individual shipping company or rail operator, of course, will have multiple services that are suitable at different times, or different types of service, different types of boat or vehicle or train or whatever, with different emissions characteristics, many factors. And so all of these need to be considered when we're doing this optimization. So you go from having thousands of possible solutions to potentially millions very quickly. And this is just for one movement, one container movement from A to B. There's obviously a single company or a planner might be managing hundreds or thousands of these. And then, of course, there's millions going on every day around the world. So having stressed the difficulty of the problem, I want to say a bit about how we're going to solve it. Although we're not starting from nothing, we have MGC Squared has been around for about 30 years. And so over that time, we've built a lot of algorithm components that are relevant to this, and we will use those as a starting point. And they're the type of applications they've been used for are hub and last mile integration, for example, in parcel networks, which tend to be at a national level, but of course have very complex interplay between different connections in the supply chain. Also, we've already applied synchromodal solutions to major ports and their surrounding hinterland, and the optimization of effectively the interaction between the and again the backhaul scheduling, maximizing the use of resources and trying to minimize empty repositioning where possible. These solutions we've already developed. So in ePIcenter, the aim is to take this technology up a level, essentially to tackle a bigger problem, solve it faster, and try and achieve some of these benefits we've been talking about. The other point about the approach is that it's, although I've very much focused on what I'd call the multimodal routing aspect of it, around that there's a lot of other capability, and the sort of things that are relevant depend on who you are in the supply chain. It's important that we have the perspective of the stakeholders in the overall logistics chain. So, for example, ports and the terminals that are operating inside a port, they are interested in this more from the effectively the throughput optimization, making better use of resources, reducing queues, and increasing effectively connectivity, increasing capacity for their facility or their port. The logistics and transport operators, the focus is on optimizing the use of their resources. So it might, for drivers, for example, which, as I said, there's a lot of news at the moment about the requirement to make good use of drivers. So making sure you do good backhauls, try to avoid them sitting in queues for hours, make sure you route them efficiently. The resource utilization for other modes, whether it's wagons on a train or vessels, and also the equipment, the container, the empty equipment itself, and any handling equipment needs to be used efficiently. And also, it's important to recognize that although we tend to think of these different modes, many operators, of course, span multiple modes. They will be managing trucks and rail movements or barge in some way, so they want an integrated picture within that hinterland. And of course, the shippers and the freight forwarders who are operating for them, there the emphasis is on first the end-to-end optimization, but also making sure that the rules are tailored, or can be tailored at least, to their requirements. So of course, chemical movements or movements of refrigerated goods or other categories have specific requirements that need to be modeled, and there might be security requirements, there might be customs requirements that constrain the solution in certain ways. And this approach is designed to try and effectively get buy-in across the board, try to offer a suite of tools that delivers an interesting benefit to the different stakeholders. So from a shipper's perspective, of course, the main driver is reduced cost and increased efficiency of the scheduling and the management of your movements, and some of the capability I described before about the ability to explore new options or to model scenarios and make your supply chain more resilient. The logistics service providers, on the other hand, are very much focused on effectively the cost and the efficiency reduction, efficiency improvement in their operation. Again, increased quality of life. I keep mentioning it, but I think that will become more important as to try to encourage people back into logistics and make the working patterns and the type of work more attractive to a wider range of people. And of course, they want integration of their network to increase capacity utilization, so they can effectively increase their capacity without big investment in infrastructure. And obviously, from the ports terminals perspective, the opportunity is by making the flow through the port more efficient. Dwell time results. You've got decreased congestion around the ports, increased capacity, and of course, a big driver is to try to reduce emissions as a result of that. So I'm coming to the end of my talk so far. Just one more point I'd like to make. It's about uncertainty, and this is a different angle on it. Another feature of ePIcenter that I mentioned earlier is new technology. And I don't want to say too much about things like the Hyperloop and the autonomous vehicles, because other partners are working on those, and there's going to be some future webinars about that. But the point about from a synchromodal logistics perspective is that we're looking at how these other technologies could be integrated into a supply chain in the future. And a direct connection, of course, is with some of the digital innovations that are going on in ePIcenter, the visibility solutions, and again, other partners can explain that better than me. But the main point from our perspective is to make good use of this data. There's a huge amount of data that could be available, and we want to make sure that it's really being used to optimize, because the volume of data that's going to be generated by all these different tracking systems and Internet of Things and so on is coming more and more mainstream. Of course, a result of that is high data volumes, and it's important that there's systems that can first process it to provide good visibility, but also then use that data to optimize and re-optimize. And in a sense, that links on to the point I made at the start about the future concept that is being explored by many groups, many research groups and many research projects. And the physical internet is quite a new idea. It's where people are just starting to pick it up and get interested in it, I think, although it's been discussed for a few years, but I think it's gaining ground. And it's essentially a new concept for managing logistics and movements and freight movements around a network. And by analogy, operating a bit like the current internet works, where you have packets of data that are automatically routed around the internet and effectively magically go from one computer to another, and it happens in a largely seamless way. Of course, there's a lot of clever technology behind the scenes, but to the end user, it appears to be a purely automated and a seamless process. And the idea is to try to mimic this in for logistics, packaging the freight up into what are known as PI containers. So these are intelligent containers that obviously have status and tracking monitoring and can be routed automatically through a network. The network is more open. There's logistics providers effectively making their services available, and then the containers are routed through this. The PI containers, I should say, are routed through this network in an automated way, exploiting some modularization and consolidation strategies to dynamically consolidate and deconsolidate key nodes in the supply chain. And the point is then you make very good use of resources, spare capacity, and effectively smooth the flow as well, using spare capacity where it's available. And this, of course, is very much a futuristic idea. There's a lot of good work being done already, but there's still a way to go yet. But the reason I mention it here in the context of this presentation is that the synchromodal algorithms that are being developed in ePIcenter, we think are relevant to this. They provide this automated end-to-end routing that allows this increased flexibility and ability to respond to a dynamic situation. So thank you very much. Just a reminder about how to stay in touch with the project. There's our website. Please also follow the LinkedIn group for updates about not just this, of course, but anything to do with the project. And we've recently set up a project on ResearchGate, which is more intended as a focus for academic and research results from the project, but is open to everyone to follow and to get involved with as well if it's of interest. So thank you very much, and yes, please, if there's any questions, please fire away.
Okay, so thank you a lot, Julian. There's one question already from Vanina. So please, Vanina. No? Oh, I thought there was...
No, sorry.
It was a clapping hand. Sorry. Yeah, true.
Okay. Nice presentation.
Okay. So does anybody have a question they want to raise to Julian, or was everything very clear? Okay. Maybe then I can myself ask a question to Julian. You mentioned the technical challenges. You also said there's also a lot of other challenges and obstacles to implement synchromodal planning. But do you think that the technology challenges are the biggest ones that we need to overcome, or are there other things that you think are very important to think about?
Yes, that's a good question. I think it's a matter of degree, because one thing that's important to say about these the algorithms that we're developing is it's incremental is the wrong word, but you can progress in terms of having increased capability and to cope with more complicated situations and bigger problems. So at the moment, I think there's an opportunity to go from the current state of the art to something that's much more automated and achieve a lot of benefits without actually solving other problems that I'm referring to. But at some point you then hit maybe a barrier where you say, well, I've already used all the information that's available to me as best as I can, and all the flexibility that's available to me as best as I can. So then the barrier becomes maybe I need a bit more information, or maybe I need a bit more flexibility. And by flexibility, I mean the opportunity to switch between modes or something like that. Maybe there's operational reasons why that's complicated. It might be difficult in a particular terminal to change the plan at the last minute because other factors, and not reasonable factors might be considered from an organizational perspective. So I think it'll be a kind of a step approach where you make progress in one area and then say, well, now it'd be really good if we could change the way we manage things in a certain part of the network, or maybe try and get a bit more information that isn't currently available, and then we can benefit from that and move forward again. But I don't think there's not necessarily one that stands out. I mean, of course, a lot of the things that ePIcenter is looking at as well to do with the visibility will help with that. The availability of data will be very interesting from the planning perspective, as well as being interesting in its own right. It's also very interesting for the synchromodal logistics ambitions, because it facilitates that a lot. So I think that will help a great deal. But yes, I mean, also, of course, there's a more general thing, which is the mindset and the way people think about it. At the moment, it's likely to meet a bit of resistance because it's this idea of things constantly changing and swapping around might sound a bit worrying and a bit difficult to manage. So that's a case of getting people used to it by effectively giving people controls so that they can limit the amount of flexibility that you have, in a sense that it's manageable, they feel comfortable with the outputs, and then as they get comfortable with how the system's working, they perhaps relax the constraints a little bit more and give it more freedom. So there's ways of tackling these issues, but it needs thought.
Okay, thank you, Julian. I see Chris also has a question. So Chris, please.
Yeah. Yes, thank you for the explanation. It was very structured and well built up. So my question, or what I was thinking, is where do you start with something from that? But then again, you clearly explained, okay, we have an existing algorithmic component. So I guess you have some sort of repository of all kinds of algorithms which you can start from. But in my perspective, that's mainly, I would say, probably on the roots and the more static components of the synchromodal challenge, let's call it. And I think you already touched upon it in your answer a little bit. My question is a bit just for my understanding, is what your perspective is on where that intelligence driving data comes from, because you give the parameters that can influence the decision you take to shift your goods onto another mode of transport in the next leg. But just from my understanding, where would that intelligence driving data come from? Does that come from the consignees that are defining the SLAs, or does it come from somewhere else? Just to understand. Thank you.
So I mean that is a good point, and to some extent, sort of taking a narrow view for a minute, we're not tackling that problem directly, but actually we are, because the approach we're using from an optimization perspective is not critically dependent on what I'd call very complete cost data, for example, or other similar information. There's an element of rule-based approach as well in the algorithms, and that's as you're I think implying is very important, because one of the shall we say the challenges that ePIcenter is setting out to deal with is incomplete data, in the sense of you may not have for every possible connection that you've got, you may not have the published latest figures about the emissions and the cost and so on. So you have to use you have to take a step back in a sense and use a more rule-based approach, where you can still come up with good solutions that are at least close to the optimal solution, if not perfect. Obviously, the better the data you put in, the more accurate the answer you get out. But we don't want to have a situation where we say, well, I don't know anything about the CO2 emissions on that leg, so therefore I can't run my model at all. We don't, so we can't do anything. We can do something. We can actually build a rule-based approach to at least approximate some of the missing information, and then build a sensible solution around it. Obviously, with the caveat that you're working off estimates in some cases. So it's the idea is that you can use this as an iterative approach. You can build a model that is useful as a starting point. It gives you good answers that are at least better than what you're doing currently. But then as you get better information, you keep on refining the outputs, and they get more and more useful and more accurate. And to a certain extent, that it's a kind of a positive feedback loop, in that you do something nice, you get a good output, and then it gives people more encouragement to go and search for or make available that additional information. There's more point to it. So that's something that we've explored in other projects, and it seems to work quite well, this sort of building up to a better solution by refinement, rather than insisting that you have a complete data set to start with. Obviously, you've got to have enough information to make a sensible a sensible output, but it's still useful even if there's a few approximations being made. It has to be managed carefully. I mean, I'm oversimplifying, of course, but that's the principle.
Okay, thank you.
Okay, then there's a question also from David from Savannah University. David.
Thank you. Hi, Julian. Thank you for your presentation. I was wondering about if, from your perspective, your research field, you are tackling somehow the network design problem.
Not explicitly in this case. Okay. Having said that, there's nothing stopping you using the tool as to help with network design. It depends what kind of question you're asking, but the sort of thing that is relatively easy to do once you've got the tool established is to experiment with different configurations of the networks. An obvious thing would be a new connection between locations. That would be a relatively simple exercise, or even moving a facility, setting up a new node at that level. So it would be useful for that kind of exercise. It's not intended to be something where you start from necessarily a blank sheet and say, what would be my ideal network? That's a different type of optimization that we're not considering here, but that's the sort of principle.
Okay, sorry, I just asked a second question. Do you think, from the network design perspective, there is some issues or some key features that should be considered to make the synchromodality task a little bit easier? I mean, so taking into account some characteristics into the network design to improve the results of your tool?
Well, actually, there's two answers to that. From an optimization perspective, obviously the simpler the network, the easier it is to solve. But on the other hand, that it sort of defeats the object, because then you have less flexibility. So it's more, I would say, the other way around. Where it would be interesting to look at is if you have a network where there's a number of bottlenecks at key points. That is very limiting, obviously, from an optimization perspective, because what you end up doing is optimizing around those bottlenecks, and you, in a sense, you pay too much attention to trying to solve the problem that you've got a capacity constraint at a certain node or a certain link or something like that. So, from a network design perspective, what's interesting is precisely to avoid that. Is to look for trying to have a flow through the network that's very balanced across all the nodes and all the links. In an ideal world, of course, that's not possible in reality, but that would be something that would be interesting to think about, which in a sense is going back to the de-risking point that I was making earlier. It then gives you more opportunities for switching between links or modes.
Thank you.
Okay, thank you, David, also for your questions. Then I think we still have time for one last question. Thomas Ambra from IMEC.
Good afternoon, everybody. Might be two questions, but short ones. First, I'm going to double check if you can hear me, because I had some problems before. Can you hear me?
We can hear you, but not very, very loud.
Okay, so those are the problems. So basically, I will try to speak up a little bit because something is happening with my computer. So,
okay.
Julian, thank you very much for the presentation. So I'm actually leading the domain of freight transportation and logistics at IMEC. And we're also involved in similar projects which actually focus on the region, such as a project called PIL. I can flag that project in the chat if you want. But we're also focusing on synchromodality as well. And I believe MGC Square is also involved in Pioneers. So is IMEC. So I'm looking forward to meeting you as well within this context.
Yes,
but
indeed.
I have also the two questions. So the first question is, what are you focusing on in ePIcenter? Are you trying to optimize the network? Are you trying to optimize a flow of a single company? How do you prioritize based on these optimization functions? That's number one. And number two, you also mentioned that you intend to change destination or mode as we go. So if you could elaborate on this a little bit more, because you also referred to shifting from barge to transportation modes like railways. So from what we have experienced is that if you want to change the mode from a barge to a train, you need to have a certain notification period, which is minimum 3 days. So if you intend to change that on the go, how is that going to happen in your algorithm? Is the notification period also considered in that algorithm? And if you switch from barges to trains, what happens then to the barge? Or if you shift from trucks to trains, what happens to the truck drivers who were idling and waiting at the terminal? How do you intend to tackle this?
Yes, that's. I think if I answer the second question first, the point about the time to switch is indeed modelled. Of course, one thing that would be nice, and this perhaps relates to what we were talking about earlier, is if you can reduce some of these times a little bit in the future, if there's ways of changing the operation. But let's assume that there is always going to be some kind of constraint on that. There's got to be. So we're not assuming that there's total freedom to change things at the last minute. From an algorithm point of view, it's achievable in that the computation can be done effectively at the last minute, but it does respect constraints. So, for example, we realize that if there's a train departing in 5 minutes, that's no good. I can't just dynamically hop onto that train and without any problem. So it respects the constraints and the processes that have to go on in a terminal, for example, or at a port to switch from one to another. But the point is that this planning can be going on ahead of time. So although we keep refining the plan, you can effectively, we're always planning ahead. So at any point in time, we have a plan for what the rest of the journey will look like, and that keeps being refined up until some point where we say, well, actually, it's not possible to change that plan anymore. There's operational constraints that stop that, so you've got to live with that plan now. Or probably in practice, you would then, if there's an issue, you would then flag that to a planner, to a user, and say, well, yeah, I've now got an insoluble problem because the constraints say that I'm going to be late and I can't do anything about it. So it is managed in that way, but it does respect those rules. The other point then about, yes, you're saying, well, what about the drivers that are sat there doing nothing? They shouldn't, that for the same reason, that shouldn't happen to that degree, because we're not sort of waiting till the ship arrives and then change the plan. As things are evolving, as the ship's effectively moving towards the port, again, oversimplifying the story, but you know what I mean. We're refining the plan all the time. So as we start realizing that maybe there's not a need for 20 drivers here, we only need 18 or something like that, that will have started to become apparent. And so already there will be a plan for what to do with those drivers. They would, instead of calling into that location, they would call into a different location and so on. It's a dynamic picture. So we're not sort of, as I say, leaving it to the last minute and then creating a plan. It's a constant refinement of the plan is the idea.
Yep, thank you.
Okay. I think these were all the questions that were raised. So and we're just in time to finish this webinar. So thank you everybody for joining the webinar. Thank you, Julian, for giving this detailed explanation on how we work around Synchromodal planning within the ePIcenter project. If you would have any more questions, feel free to send us by email your questions, and we will be happy to answer them. As I said, the session is recorded, so we will also make it available to all of you after, in a couple of days probably. So thank you very much, and have a nice evening. Goodbye.
Goodbye.
Thank you. Bye-bye.
Thank you. Goodbye.